Hello, and welcome back to Trick Equals Treat, where solving math problem isn't just a task, it's a reward. Today, we are looking at a beautiful example of symmetry. Take a look at this figure. We have a square interacting with a circle in a very specific way. One side of the square is tangent to the circle. It just kisses the edge, while the opposite two vertices are sitting perfectly on the circle's circumference. Here's the challenge. Can we find the area of the square? Now, usually to find an area, we need a side length, but we don't have that. The only clue we are given is this tiny detail. If we find the midpoint of the arc between the square's corners, the distance from that arc to the side of the square is exactly 2 units. That's it, just the number 2. Is it enough information to crack the code? Let's find out. Before we calculate, we must navigate. Let's place some points in our map. Since we want the area of the square, let's call the side length A. Because of the symmetry here, if we draw a line right down the middle, connecting point C, the midpoint of the arc through F and down to G, we create the spine of our figure. This line passes right through the center of the circle, point O. And since a circle is involved, let's call the radius R. Here's our first major insight. The line segment GC represents the diameter of the circle, so its length is 2R. But look at the geometry. Look at the diameter in segment GF. The diameter is also made up of the square's side, GF, which is A, plus that little gap we were given, FC, which is 2. So we can write our first equation, A equals 2R minus 2. Let's call it equation 1. Great! We have a direct link between the square and the circle, but we have two variables, A and R. In algebra, one equation isn't enough. We need a second relationship. This is where we need to hunt for a triangle, specifically a right-angled triangle. Let's connect the center O to the corner of the square, point A. See triangle AOF? Let's break down its size, the hypotenuse OA. This connects the center to the circumference of the circle, so it's just the radius, R. The height, AF. Since F is the midpoint of the square's side, this is half of A, or A over 2. The base, OF. This is the tricky one. The whole radius is OC, length R. We know the right part FC is 2, so the remaining piece OF must be R minus 2. Now, we apply the most famous Pythagorean theorem in geometry. Base squared plus height squared equals hypotenuse squared. So what we get in our case is OF squared plus AF squared equals OA squared. Substituting our values, R minus 2 squared plus A over 2 squared equals R squared. The physics of the problem is done. Now we just let the algebra take over. We now have a system of two equations. Now look at our first equation. A equals 2R minus 2. Let's simplify that. If we divide by 2, we get A over 2 equals R minus 1. We can plug this directly into our equation 2. R minus 2 squared plus R minus 1 squared equals R squared. Expand the squares. R squared minus 4R plus 4 plus R squared minus 2R plus 1 equals R squared. Combine the terms and we land on a clean quadratic equation. R squared minus 6R plus 5 equals 0. We can factor this easily. R minus 5, R minus 1 equals 0. This gives us two possible solutions for the radius, r equals 5 or r equals 1. Let's look at the first case. If the radius is 5, we go back to our equation 1. A equals 2r minus 2. A equals 2 times 5 minus 2. We get A equals 8. The question asks for the area of the square. If the side is 8, the area is 64, and there is our primary answer. But wait, we promised academic seriousness here at Trick Equals Treat. What about that other solution, r equals 1? If r equals 1, then A equals 2 times 1 minus 2, which means A equals 0. The area would be 0. Does this make sense? Actually, yes. Imagine the square shrinking. If the square shrinks all the way down to a single point at the very bottom of the circle, the side length is 0, and the gap to the top of the arc AB would be the full diameter. If the radius is 1, the diameter is 2. So mathematically, a point is just a degenerate square that satisfies our condition. Though for our geometric puzzle, the area of 64 looks much more like a treat. It is satisfying to see how a single number 2 locked the entire shape into place. If you enjoy this blend of geometry and algebra, make sure to like and subscribe for more math tricks that are always a treat. See you next time.